Hello, everyone, and a very warm welcome to this, our final presentation of the day. There is still panel discussion to come after this, after the networking break. But yes, a very warm welcome to Ali Alp, who's going to be looking at when events meet clusters. So if you could just unmute your video and your sound for us, please, Ali, that would be great. All right, wonderful. Well, thank you for joining us, Ali. Really looking forward to
Hi.
this. The stage is yours.
Yeah, thanks for having me. So, just a sec. Yes. So let's get started. When events meet clusters, building reactive microservices and Kubernetes. My name is Ali Alp. I'm a distinguished software architect at BrainLab. You can get the slides if you wish by scanning the QR code on your screen. I give some time if you want to scan it. Also, you can see all the related details regarding this talk at alialp.de under talks, and you can find today's summit. So let's get started. Let's meet our friend Keizo. He is a cool software developer who loves coffee like me. And today is another day in the office and he's craving for his morning coffee. He goes to the coffee machine and selects espresso. The coffee machine says, "Sure, 1 moment please." And Keizo is very excited because in 1 moment he's gonna get his morning espresso. And as promised, 1 moment later, his coffee is ready. Everyone is happy. But wait, let's take a different path. The microservices path. Let him select the espresso. Let the machine says, "Sure, 1 moment please." But this time, contacting bean grinding service, requesting water heating service, waiting for pressure pump service, fetching brew profile from global aroma registry, syncing metrics with observability cluster, retrying log service again. The result is unhappy Keizo. Why do our microservices still wait when our users expect them to instantly react? Maybe we scale late. If you are running your workload, for example, in Kubernetes, you know that it does scale even if you use HPA, the horizontal pod autoscaler. You know that it's based on the mainly CPU usage, and until you get the CPU usage up, I mean, it can be already too late. Maybe we detect failure after users do. I mean, maybe our boss calls us and says that the application doesn't work anymore, and that's the time that we start looking into it. Way before that, users start having struggles with the application and blah blah. Maybe we couple services until they become slow. This is my favorite one. And I think that this is a big problem and a very common problem in software architecture, that people couple stuff. I don't know, they like maybe to see all the projects in one repository or deploy them side by side or use local host for whatever reason. We love coupling. Or maybe we build clusters, but not living systems. So, are you ready to see how we can build microservices that react instantly and recover automatically instead of waiting and breaking? Then, if the answer is yes, which mine is, let's get started. Let's say we have a food delivery app, and ironically, if you do, you literally must think about rainy days. Because in rainy days, for example, during a sudden rainstorm, you can get a sudden tenfold spike in over 60 seconds. And the reason is that people, they got back from work, they are tired, lazy, they want to wear their pajamas, and it's raining and they don't want to get wet, so they want to order in. They want to have their food at home. And that's where your spike can happen. And you shouldn't expect the users to be accommodating and saying that, okay, this is rainy time and everyone is ordering in, so these guys are poor and they don't have enough resources, so let's don't put too much pressure on their system. No, if the system gets slow by the spike, then people will get more frustrated because they're hungry, so they will refresh more, and you will end up with even more incomplete requests in your system. What do we want? We want a system that it recognizes the spike as an event. You may think that the spike can be is like a I don't know, natural disaster. Like, for example, in Europe, the earthquake is considered a natural disaster, but in Japan, for example, earthquake is an event. Interestingly, monthly events that can happen every month, 1 or 2 times. So you need to be prepared for it. Why events reduce failure is that, as I said, most of system failures are from coupling, and coupling will cause, if you have one slow service and they are coupled, so it slows everything. One failing service breaks everything. And the scaling service overloads everything. So if you have, for example, you decided, okay, I have a spike, I'm gonna increase the number of pods of, I don't know, checkouts, and then during doing that, you are going to make a long queue for other guys, other microservices that they want to do checkout, and they are waiting for your checkout services to come up. Living systems avoid dying from one malfunctioning cells. If one microservice fails, the whole system shouldn't collapse. And we want a system that it reacts instantly. I mean, if I tell you as an event that there is a lion behind you, and you receive the event, and you say that, yeah, I got the event. But if you don't do anything about it, you're gonna get eaten anyways. I mean, the examples are about food delivery, so I thought maybe we can have a lion eating you as an example. And by reacting, I mean, it heals automatically and it scales the consumers. You say, no worries, there's a cool thing called Kubernetes. I'll run it in Kubernetes. But wait, Kubernetes is excellent at running workloads, restarting the failure, and which it calls healing, and scaling based on CPU usage. Kubernetes does not understand business events, demand surge, like for example the rainy day for the food delivery, workflow triggers, if something triggers that you need more workflow on somewhere else in your cluster. Kubernetes does not understand these things. You can think of Kubernetes as a muscle. It's not a nervous system. It just good at taking a state and making it happen. So what we need actually is a nervous system for our ecosystem. We need something that it has long-term memory. So if you are if you are ordering food, and in your food delivery app you have a basket, and if I, as a hungry person in a rainy day, I'm adding the foods in my basket, but because of some reason you are scaling up because you have a lot of load, and or if because of the load the app crashed, then the new one that comes up, you don't want empty basket. You spend time, hungry time, and chose the cheeseburger and salad to your basket. So you want something that it remembers what has happened, that it can the new pod can come up with those things in the basket. And you need something that it has a notification system. I just imagine that if you want to poll things, right? So polling, what if you look at the train station, imagine that if you suppose to every, for example, 5 seconds or 10 seconds to check the board if the train is late, or if the train is coming, if the train is what. Instead of that, it's much more convenient if there is an announcement if the train is going to be late, then you get simply the announcement, and you don't need to check all the time the board. And we need something to replay when things fail. So if you have a checkout service, you don't want it to, if during doing the checkout, during taking the money, something went wrong and it crashed, or you scaled it up or down or whatever, you want to be able to, when the new service the pod comes up, to be able to take the same steps that it was taking before failure. So you want something that it has ability to go back in time and replay all the steps again. Any guesses what is that something that we are talking, that it has long-term memory, notification system, and it can replay when things fail? Yes, we need Apache Kafka. Kafka is the spine of our system. So everything, every stimuli you can think of the body, that you touch anything, that stimuli needs to pass from the spine. So far, we have Kubernetes, the muscle, who does things and make things, the state possible or happening, and the Kafka, which is the spine, which is the highway of the events that are passing. But we need a full working nervous system. Any guesses what is missing? Touch something hot and your hand pulls back instantly before even your brain processes it. So this is called reflex system. So when you touch something hot, literally the stimuli, the sensory neurons will take it to your spine, and it comes back. It doesn't travel all the way to your brain, because if it does, it takes a long time and it's already too late. And that's the thing that the CPU surge needs to happen, that the Kubernetes understand that things are not doing well and stuff like that. We need a reflex system. Meet Knative, our reflex system. Knative, it watches the Kafka topics. So it's the Kafka being the spine. And when an event arrives, Knative instantly activates the exact workload needed. It scales the consumers up under load and down to zero when it's idle. Now our nervous system is complete. We have Kafka that they receive the events, the stimuli, the touching the hot thing. We have Knative that it will detect, so it's the reflex system instantly. And Knative tells the muscle, the K8, to spin up the consumers now. And Kubernetes will just do that. This makes your architecture feels like a living, responsive organism, not just pile of YAML files. I wanted to mention also some patterns for building reactive microservices. First, the most famous one, I can refer to event choreography, which the order is placed, the payment confirmed, package packed, out for delivery. As you can see, each step is waiting only for the previous one, and it just knows where to send, and the next one will be waiting for the previous one again. So they are not coupled, and all the good stuff. And the second one I can mention is event sourcing. And you can think of event sourcing for bank accounts. The bank account is some of the transactions. There is no field that it holds the total money that you have. It's always being calculated from the beginning. So event sourcing in our terms is sum of Kafka events. So it's like a live status that is being calculated each time that you look at it. And CQRS with Kafka streams is with commands you write, with queries you read, the fast views that Kafka streams keep it live and updates them as they go. And you will get scalable, predictable, clean separation between the command and queries. As an organization, what you gain is a massive reduction over provisioning, because you don't need to think about the worst case scenario and say that, oh man, you know, at 8 o'clock, I need 100 pods to be running, and I need to over provision it because I don't know how much tonight I will get load. You get better stability under unpredictable workload, because that 100 pods that you thought that you need to make it run in order to handle the load, maybe it's not enough. Maybe it's, at that night you need 200 pods. And you will have fewer cascading failure, because when you are based everything on the events, so services are not coupled. So if one service fails, you will have a localized failure, not a global failure. And you have simpler understanding of systems behavior, because they have a simpler scope. And with that, you can understand one service very well, and you don't need to understand the whole global system in order to understand one service. And you will, because of these things, you get improved developer autonomy. So if you build microservices, stop pulling. Stop checking the database for every 5 seconds, because if you do it every second, what you will have is you bend the database to its needs. But if you do it every 5 seconds, maybe the database can handle it. But what will happen is that that service is always 5 seconds late. Stop wiring services tightly and start treating the events as primary source of truth. Let the platform react for you. And least but not last is, or last but not least, is that the reactive systems aren't faster machines. They're better listeners. And you can scan this QR code if you are interested to get more into details of the whatever I discussed in an article. And by that, I leave it to Flip if there are any questions from the audience.
Wonderful, wonderful. Thank you for that, Ali. We've got one question here coming from Bayer. Aren't the microservices handled through interrupts, in brackets, hardware interrupts?
Aren't the microservices handled through interrupts, hardware interrupts? Can you elaborate on that? Because I don't know which microservices you are talking about. Yeah, polling means that, so you have polling is like checking the, for example, the I don't know, a field in database. That is polling, and it's not. I'm not talking about the assembly level of polling, but the polling, the mechanism polling. Yeah, exactly. Application level, not very low level. Yeah.
Okay. All right. Good stuff on that. Wonderful. Any other questions at all for Ali right now? Okay. All righty. Well, thank you so much for a wonderful session, Ali. Really, really valuable addition to the agenda. You feel free to reach out to Ali on LinkedIn. I'm sure he'll be happy to connect. Right, we are at the next networking break now, so you have some time to to relax, get a coffee, maybe like Keizo, go and find a coffee somewhere. I think I need one. My little one woke me up at 4:30 this morning, so I'm
Oh, yeah.
to the point where I'm needing some coffee at lunchtime. So yes, wonderful. Thank you so much for joining us, Ali. We'll be back in around 40 minutes or so with more great
Thanks
content.
for having me.
See you all then.